All right, so we're going to get into the next method of solving a quadratic equation. Remember last time we talked about the graphing method and we talked about the square root method. Now we're going to talk about solving a quadratic equation using factoring. Sometimes we're going to have to do that. Okay, so in order to do that, we have to review how to factor. So you have 4 problems in there at the beginning of your notes. Go ahead and try to factor those 4 problems. Stop the video, and then start it back up once you have them factored, and I'll run you through the answers or the solutions pretty quickly so you can just review how to factor. Okay, so for the first one, it should look like this, right? We factor the first term into x and x. In the last term, we need factors of negative 24 that add to negative 10, and that's negative 12 and 2. Okay? Number 2 should look like this. So now we're going to factor the first term into 3x and x, here and here. And then when we create our factors of negative 5, we understand that one of those factors have to be multiplied by 3. And one of them will be multiplied by 1, which doesn't change it. So anyway, multiply one of your factors by 3, add the other one, and you have to add to negative 2. And the way that we do that is to multiply the 3 by 1, so 3 times 1 over here. Add negative 5, you get negative 2. So the 3x and the 1 get linked, the negative 5 and the x get linked. For number 3, it should look like this. Factor out a GCF first, which is 4x. You're left with x squared minus 9. And that's your difference of squares, and so your quick factoring of x plus 3, x minus 3. Number 4 should look like this. Factor out a 2 for a GCF, and then if you don't recognize this as a perfect square trinomial, to where you can square root the first, square root the last, and then 4x times 1 times 2 gives you 8x, you can always still do the same process where you got to factor 16 down first, which could be 16 and 1, 8 and 2, or 4 and 4, and then choose one of those factor pairs, plug them in, and then your factors of 1 are just 1 and negative 1. 1 and 1 and negative 1 and negative 1, and just start playing around, right? Try to find the right combination. Either multiply your factors over here by 16 and 1, or by 8 and 2, or by 4 and 4, and see which ones will let you add to 8x. You'll find that it's 4x plus 1, 4x plus 1. Okay? Got a factor. All right. Now, also a quick review on how to find solutions by graphing. So let's graph this guy real quick, and we can do this together. This guy is going to open up because A is positive. The vertex comes from opposite B, which is 6, over 2 times A, which is 2 times 1, or 2. So this x is 3. If you plug in 3, 3 squared is 9, then you get negative 18, then you get plus 8. This is going to be negative 1. So 3, negative 1 is here. Your axis of symmetry goes through here. It's a vertical line, so the equation is going to be x equals 3. Now we need 2 x values next on the same side of the axis of symmetry. I'm going to choose 2 and 1. Now if you plug in 2, 2 squared is 4. Negative 6 minus 2 is negative 12 plus 8. And this gets you 0. You plug in 1, you get 1 squared is 1, minus 6 plus 8, which is actually 3. So you go plug in 2 comma 0, 1 comma 3, and then mirror image these guys. And your graph looks something like that, which is pretty terrible, but there you go. Your solutions. Do you remember how to find the solutions in the graphing method? Remember that solutions are also called roots of the equation. They're also called zeros of the function, and they're also called x-intercepts. So where does this parabola hit the x-axis? It hits it at 2 and 4. So those are your solutions. My question for you is, why are they called zeros? Well, they're called zeros because what are the coordinates for that point? Well, it's 4 comma 0. What are the coordinates for that point? Well, it's 2 comma 0. both of our solutions have a y coordinate of 0. That's because if I plug 2 in for x, y will be 0, and we see that here. If I were to plug in 4, and I haven't done the math yet, but if it's a solution, then that means if I plug in 4 for x, then y is going to be 0 again. 4 squared is 16. Negative 6 times 4 is negative 24 plus 8, and that is actually going to be 0. So y is going to be 0. So what that tells me is, whatever the solutions are, whatever the x values of the solutions are, if I plug those into the function, y is going to be 0. That's why they're called zeros. Okay? Now, if I don't know what the solutions are going into a problem, say like this one. If I have a function y equals x squared minus 6x plus 8. I don't know what the solutions are here, right? But from what we just were talking about, what I do know is, whatever they are, when I plug those in, y is going to equal 0. Okay? If I substitute the solutions in for the x's in the function, y is going to be 0. So since I know that's going to be the case, I'm going to actually plug in 0 for y. The other reason why I'm going to do that is because, yes, we can definitely solve a quadratic function by graphing, but not every solution for a quadratic function is going to be nice, pretty, whole numbers, nice points. Okay? Sometimes they get very ugly. And when we get to the next class and talk about the quadratic formula, some of those solutions are going to get really ugly. Okay? So I don't want to have to try to go hunt on a graph to find the solution sometimes. Sometimes it's going to be too hard to tell what they are. So, functions we graph. This is a function, we would graph that. So equations we solve. So I also want to be able to turn that function into an equation. And since I know that we're looking for solutions, and whatever the solutions are, if I plug them in, y is going to be 0, I automatically know that y is going to be 0. So I replace y with 0, and then I get an equation that now I can solve. And it's going to be a lot easier to do than by the graphing method. Okay? Now, how are we going to do that? Well, if we go back to the last class as well, we talked about the square root method of solving. When is the only time it is appropriate to use the square root method? Well, when b is 0. Okay? When b is 0. If you're missing that linear term, or that x to the first term, then you can use the square root method, right? So I'm on the left-hand side here. The square root method has is adding 25, then square rooting both sides and getting plus or minus 5. On the right-hand side, we recognize the fact that actually, before we add 25 to both sides, we can actually factor that. So we factor x squared minus 25 into x minus 5, x plus 5. It's one of those difference of squares. And so we just get x minus 5 and x plus 5. Now, there's something called the zero product property that says, if I've got these two factors, and factors are just two things that are multiplied together, then here's what this equation says. This equation says I'm taking two things that I'm going to multiply together, and they have to equal 0. The only time that happens is if this is 0 or if this is 0. Or maybe both, right? But one of them has to be 0. That's the only way I can multiply two things together and get a result of 0. Now, I don't care which one's 0. So I need to know when x minus 5 is equal to 0, and I need to know when x plus 5 is equal to 0. So how do I find that out? Well, I actually set x minus 5 equal to 0 and x plus 5 equal to 0 and solve for x. Add 5, subtract 5, we get 5 and negative 5. Which, hey, looky there, our solution on the left-hand side was plus or minus 5 also. So what that means is we could factor our quadratic expression here and then take our factors and set them equal to 0. All right? That's what we're going to do. So, for example, this guy. So this was a function that was y equals x squared minus 10x minus 56. But since I'm finding solutions, and I know that for the solutions, y is going to be 0. I'm going to replace this with a 0, give myself an equation that I can go solve. B is not 0 here. B is actually negative 10. So I can't use the square root method. I'm going to have to factor. So I factor this guy down into x and x here. I need factors of negative 56 that are going to add to negative 10. And you can come up with those on your own. But you're going to get negative 14 and positive 4. Okay? Now again, this equation says I'm multiplying two things together and I have to get a 0. The only way that happens is if one of them actually is equal to 0. So, since I don't care which one, I'm going to actually set both of these factors equal to 0 and solve. Subtract 4 and add 14. Okay? All right? Now, I need to add 2, and I know that you're looking at this, and I haven't even acknowledged it yet, but what that is telling you is basically that you have to be in standard form of a quadratic function, right? In other words, I need to make sure that I know where the y was. Since I'm plugging in a 0 for y, I need to see a 0 in this equation. Okay? If I don't see a 0 in this equation, then I've got to move everything over to one side so that I do get a 0. And I'll show you what I mean in a couple of examples. Okay? I've got to see where the y goes. Okay? For example, number 7, I know where the y goes. It goes right here because that's our 0. Okay? So I'm substituting 0 in for y. That's how I know that y goes there. So this guy, I'm in standard form. B is not 0. I actually have a b, a linear term here. So we've got a factor. So go 3x and x. And I'm not going to spend a lot of time on the factoring part here because you should know that already. If not, get in here and see me so we can go over it. Now I need factors of 5 that are going to that I'm going to have to multiply one of them by 3, add the other one, and get 16. Well, that's if I multiply 3 times 5. So I get plus 5 here, plus 1 here, and I get 15 plus 1x, which is 16x. Okay? Now, again, if I'm going to multiply these two guys together and get a result of 0, one of them has to be equal to 0, so I'm going to set these guys equal to 0 and solve. I'm going to subtract 1. I'm going to divide by 3. Subtract 5. And there are my two solutions. And so there's an example where I wouldn't want to use the graphing method to find those solutions because it would be too tough to tell where the line is hitting negative 1/3 on the x-axis, right? Because remember, these are solutions. So if I were to graph that parabola, the parabola would hit the x-axis at 5 and negative 1/3. Okay, that's what we're doing here. Okay, a few more examples here of some variations of what you might see. And then I'll let you work on your own. Number 8, okay, and I keep forgetting to talk about this, but the first thing you need to look for when you are factoring, right, because we're going to factor this, is a GCF. There's a GCF of a 5 here. Now go factor your trinomial. So we can go x and x. I need factors of negative 8 that will add to negative 2. I don't have to worry about multiplying any of the factors by anything because these coefficients on the x's are just 1s. Well, the factors of negative 8 that add to negative 2 are negative 4 and positive 2. Now, this sentence, this equation is telling me that I'm going to take 3 things. I've got 3 factors. So there are 3 things that I need to multiply together to get back to the original expression of 5x squared minus 10x minus 40. And it doesn't change anything. Now if I multiply all 3 of these, when I multiply all 3 of these and have to get a result of 0, that means one of these 3 have to be equal to 0. Now I don't care which one. So 5 can be equal to 0, right? No, 5 can't be equal to 0. So that doesn't really make a difference to us. That's really not going to create a solution for us. But as long as the other 2 are equal to 0 at some point, then we'll have solutions. So I set the other 2 equal to 0, subtract 2, add 4, And there are my two solutions here. So if I were to graph that quadratic, the parabola would hit the x-axis at 4 and negative 2. Okay? And you see that there. All right? Same thing with, I want to factor out a greatest common factor of 2x. Get x squared minus 5x minus 6. And then I'm going to factor this into x and x, negative 6 plus 1. Okay? Negative 6 and plus 1 are factors of negative 6 that add to negative 5. Now, again, I've got 3 things that I'm multiplying together to get 0. That means one of these 3 needs to be equal to 0. It makes enough sense to set 2x equal to 0 because I can divide by 2 and x is 0. So I'm okay to go ahead and do that. So you add 6 here, subtract 1 here, and there are your solutions. There's 3 of them. This means that there's 3 x-intercepts. But for a parabola, you can't have 3 x-intercepts, which is true. But this is not a quadratic. This is actually a cubic. So we have 3 solutions. Okay? All right. Last example that I'll walk you through, and then I'll let you work a few on your own. Here's what I was talking about before. I don't see a 0 in this equation. I don't know where the y was supposed to go. Okay? So I've got to get it equal to 0. I've got to add 225. And then I get x squared plus 30x plus 225 equals 0. Now I know where the y was supposed to go. So now I'm in standard form, and I can go and factor this into x and x. Now I need factors of 225 that will add to 30. Okay? And that is going to be, I believe, 15 and 15. Yeah. 15 times 15 is 225. Okay? And then they add the 30 there. So now I've got these 2 factors that I'm going to set equal to 0 to find out when they're going to be 0. But they're both going to give me the same result, negative 15 here and negative 15 here, which means that there's actually only one solution, and that's negative 15. So there's only one x-intercept. But wait a second, Mr. Smith, there's supposed to be 2 x-intercepts. Well, no, if you recall from the last set of notes, sometimes the vertex is on the x-axis, and that gives us only one x-intercept, only one solution. So this is possible to only have one solution. Okay? All right. Now, I'm going to turn you loose, let you work this. So go ahead and give it a shot. And when you're done, start the video back up and see if you're right. Okay? Did you get this? Okay? I've got to get this equal to 0, so I subtracted the 100x to the other side. Now I know where the y goes. And then I factored out a GCF, but if you'll notice, I factored out a negative 4x. Okay? I want to do that because I want my lead coefficient, I want my first coefficient to be positive when I factor. So that's how that happens. Remember that when you factor out a GCF, you're dividing each term by that GCF. So you're actually dividing everything by a negative 4. So you're going to change all the signs over to positive. Okay? Then you go factor 4x squared plus 20x plus 25, which will factor into 2x plus 5, 2x plus 5. And now you have 3 factors to go set equal to 0. Only 2 of them are going to give you the exact same thing. Those 2 factors are exactly the same. So we're only going to be left with 2 solutions here, 0 and negative 5/2. Okay? Make sense? Right? Try this guy and see what you come up with. Start the video back up. See if you're right. Okay, did you get this? You got to add the 25x to both sides first, because again, it's got to be equal to 0 so I can see where the y goes. But then you factor out a GCF of 5x, and you get 5x times x plus 5. Our factoring is done. So now you take 5x and set it equal to 0, x plus 5 and set it equal to 0, and there are your solutions, 0 and negative 5. Okay? All right. You've got 13. You need to see that. So hang in there. Okay? Here's 13. I covered the answers up because I couldn't get the solutions off of the slide. So go ahead and try to solve this one. And stop the video, see what you come up with, and start it back up and see how you did. Did you get this? Okay, so factor out a 4x. Then you can factor what's left into x minus 5, x plus 5. Set those factors equal to 0. And you should get 0, 5, and negative 5 for your solutions. Okay? Good. Some story type problems for you. You decided to plant a bulb garden. You want the length of the rectangular garden to be 3 feet longer than its width. The bulbs that you have will cover 88 square feet. What should be the length and the width of your garden? Okay, well, we're talking about covering an area, which is length times width for a rectangle. Okay, the width we don't know, so let it be W. The length we don't know either, but it's going to be 3 feet longer. So we can take W plus 3. Okay, now the area is 88 square feet. The length is W plus 3, and the width is just W. Okay? Now, here's the thing. We're going to have to sort of go in reverse a little bit, right? I have to get, in order to solve this, I have to get this equal to 0. And the only way that's going to make any sense is if I go ahead and distribute this W and then subtract the 88 from both sides. It's a little weird. So I distribute that W and get W squared plus 3W. Now I'm going to subtract 88 from both sides. And I get 0 equals W squared plus 3W minus 88. Now we go factor that. And I'm going to do that over here. And factor it in too. I need factors of negative 88 that will add to positive 3. Well, 8 and 11 seem like they're going to do that for us pretty well. So go plus 11 minus 8. And then you set your two factors equal to 0. Subtract 11. Add 8. And there you go. What should be the length and the width of your garden? That's the question, right? So to answer the question, the width should be what? Well, it can't be negative 11 feet. It doesn't make any sense. So the width is 8 feet, which means the length, you're not going to be able to see this back there, or maybe you can, is going to be 3 feet longer than that, or 11 feet. Okay? Cool? All right. Then try this one on your own. And stop the video, see what you come up with, start it back up, and see how you did. Okay, here's what you should come up with. A little trickier. So the original garden, the length was 3 times the width. So the width is W, the length is going to be 3 times that, or 3W. But then we're going to increase the garden by 5 yards on both sides. So now the new width is going to be W plus 5, where the new length is 3W plus 5. So the area is going to be 312 square yards, so we go here. Area is equal to length times width again, so we've got to multiply W plus 5 times 3W plus 5. So we have to FOIL that out and then subtract the 312 to get this in standard form. And you end up with this guy right here. Then you factor that, and that was a little tough, finding factors of negative 287 that we're going to add to positive 20. Took me a minute too, so if it took you a minute, hopefully you did finally find them. But it's 41 and negative 7 because you have to multiply the negative 7 times 3. Okay, there are your factors. You set your factors equal to 0. Now, I crossed out the negative 41 over 3 because lengths and widths can't be negative. So we can't use that one. The width is 7. W is going to be 7. That gives us some positive lengths and widths. Excuse me. And so that makes more sense. Okay? All right, one more here for you to take a look at. The volume of the following prism is 36 cubic centimeters. Find the value of x. Do you remember how to find volume? Well, volume is length times width times height. Okay? This volume is 36 cubic centimeters. The length is x minus 2. The width, you can call it whatever, is 2. And the height is x plus 5. Okay? Now, I'm going to multiply the right-hand side out because, again, I have to subtract the 36 over to make this in standard form. So I'm going to go 2x minus 4, distribute that 2, x plus 5. Now I got a FOIL. And so 36 is equal to 2x squared plus 10x minus 4x minus 20. 36 equals 2x squared, combine your like terms here, plus 6x minus 20. Now I'm going to subtract 36 from both sides. We get 2x squared plus 6x minus 56. And now I've got a factor. Okay, I'm going to factor this into 2x and x. And now I need factors of negative 56 that are going to add to 6. I could try 8 and 7. It would have to be, 8 and negative 7. Maybe. Let's see. 2 times 8 is 16. That's going to, plus negative 7 is going to give me 9. 2 times negative 14, 2 times negative 7 is negative 14, plus 8 is negative 6. Oh, close, just wrong sign. So all I'm going to do is make the 8 negative. So the 2 has to be multiplied by the 7, so we're going to get a plus 7 here and a minus 8 here. Oh, look at that. I could have factored out a GCF. I should have factored out a GCF right here. But I didn't. It's my fault, but I could still factor this. Set my factors equal to 0. And be in good shape. Now again, lengths, widths, and heights can't be negative. So when you get negative 7 here, you can't use it. Here we're going to add 8, divide by 2, and get 4. So the value of x is just 4. Okay? Hopefully that makes sense. Give it a try. Give your homework a try. It's out in Canvas. And we'll see you next time.